Good morning. Today we are writing linear equations in point-slope form. This is a new form that we have not seen before. It's called point-slope form because we're incorporating a point and a slope. So it says the point-slope form of the equation of the non-vertical line, so not a vertical line, is through a given point x1, y1 with the slope m. So we've found our slope before and we know how to label a point xy. So this is our new equation right here. So it's y, I'm going to use different colors here to show you what I mean. It's the letter y, not what we're plugging in, the actual letter y, minus y1, which comes from our point. So y1 is part of our point that we're plugging in, equal to our slope, which is m, whatever our slope is, and then in parentheses, x minus, so this is just the letter x, minus x1, which also comes from our point, whatever number x1 is. So now, easy way to remember this, you guys, isn't slope, if we have 2 points, y2 minus y1 over x2 minus x1, all they did to get this equation was take this piece, and the opposite of divide would be multiply it. They moved over here, x2 minus x1, to get rid of it. Isn't that what this equation is? M equals x minus x1, which is just the first x minus the second x, equal to y minus y1, or y2 minus y1. It's the same equation. All we're doing is plugging in our slope and a point, x, y, this is my one point that I have, into my equation. So let's plug it in. It says the letter y, so literally write the letter y, minus, from the equation, y1. And y1 right here is negative 3. Those two negatives we know make a positive. Then it says equals, and then right here our slope, or our m, let me get this out of the way so we can see our equation. You can also look at this one over here. Our m, or our slope, is 2. And then in parentheses, x, the letter x, minus x1 from our point, which is 4. There is no solving involved. This is our answer. This is in this form, point-slope form, because we have our point here, 3 and 4, and then our slope, which is 2. Let's do the same thing on this one. We're going to plug it into our equation. Here is my point x, y, and that's my one point that I have in, so it's going in for the ones that have the little ones. And then my slope is negative 1. So plugging this in, we have y minus y1, which is 5, equal to our slope, and our slope right here is negative 1. And then in parentheses, x minus x1, which is 3. So there's our equation. We're going to do the exact same thing now. We're going to plug our point and our slope into this equation. But the only difference is this time we have 2 points, so we need to pick one. And first we need to find our slope. So I'm going to use my slope formula, y2 minus y1 over x2 minus x1, to find my slope. So I'm going to label these xy first point, second point, and plug them in. y2 minus y1, we have 2 minus 10. x2 minus x1, we have 4 minus a negative 3. Those two negatives make a positive. 2 minus 10, there's more negatives, that's a negative 10, would give us negative 8. 4 plus 3 is 7. So there's our slope. Now we just need to plug everything into our equation. Y minus y1 equals our slope, and then x minus x1. Same equation that's right here. It says pick one of the coordinate pairs, one of the points. We don't need both. I'm just going to pick the first one. So my equation would read y minus y1, which is 10, equal to our slope, which is negative 8/7, and then x minus x1 right here, which is a -3. Those two negatives make a positive. So this would be my answer. But if this wasn't the answer choice, for example, if it was multiple choice and this wasn't one of my answers, I could use the other point to see if that would be one of the answers. So y minus y1, or instead this one is 2, equals our slope, -8/7. And then x minus x1, or right here is 4. So these are both correct answers. On a test, I would accept either of these. They're both okay. So let's find our slope on our next problem. xy first point, xy second point. So I'm going to plug these into my slope formula, which is right here. y2 minus y1, so we have 6 minus 4. And then x2 minus x1, we have 17 minus 9. 6 minus 4 is 2. 17 minus 9 is 8. And we can simplify that by dividing by 2 to give us 1/4. So that's our slope. And now we need to pick one equation, or one point, to plug into our equation. So I'm going to pick this first point because they're already labeled with 1s. Y minus y1, which is 4, equal to our slope, which is 1/4. And then x minus x1, which is 9. So this would be my answer. Now, my point on this one was 4 and 9. X was 9 and y was 4. So if I was given this equation, I could find what my point is from this equation, as long as these are both negatives, because that's what our equation has, negatives here. In order to get a positive like this one, we had a negative and a negative making that positive. So let's go to the next slide here. On slide 3 it says graph this equation. Well, instead of solving for y to graph y equals mx plus b, we can find our slope right from our equation. Our slope is right here in front of the parentheses, 2/3. And our point, oops, not b. Our point is x and then y. So x, our first one right here, is 3, because this is a negative, that's part of the equation. And y, ooh, this isn't a negative, so in order to get this 2 positive, we had to have 1 minus from the equation, and that means 2 also has to be negative. So y is actually a -2, because this comes from the equation, and this one comes from the 2. So this is our point. We can graph this. Well, let's just plot our point. This is x, this is y. Our point is 3, -2. So x is 3 to the right, y is -2, down 2. So there's that point. We graphed that. Now we can just use our slope to create the line. Rise over run. So rise 2, 1, 2, and run 1, 2, 3. Rise 2, run 3. Or instead of up and right, we can go down 2, 3 to the left. Down 2, 3 to the left. And there's our nice straight line. Make sure you put arrows on the ends to show that it could go on in both directions. Let's try the next one. Let's find our slope in front of the parentheses. Right here it's 1/2, or 1/2. And then our point, x and then y. Well, x right here, this one made a positive, so just like this one over here, there had to be one negative from the equation, and that means to get this to be a positive 2, 2 also has to be negative. So x is -2. And y, well, this negative is there, so y is just 2. So let's plot that point. This point, x is -2, and then y is +2 right there. It's like following the directions, x and then y. And our slope is 1/2, rise over run. So from this point, up 1, over 2, up 1, over 2, up 1, over 2. or down 1, 2 to the left. So there is our equation, and draw lines or arrows on the ends to show it could go on. Alright, let's keep going. We're going to do this first one together, and then I'm going to have you try the second one on your own. So this one, our slope, in front here, that's just a negative, so it's really a -1, so our slope is -1, or as a fraction, -1 over 1, so we can do rise over run. And then our point, x and y, x right here, it's negative, those match, so x is 2, and y is just 1. Those ones, both x and y are positive. So if we plot that point, x is 2 to the right, y is up 1 right there, 2, 1. Our slope is -1 or down 1, positive 1 is to the right. Down 1, positive numbers are to the right. Down 1, to the right. Or up 1, 1 to the left. Up 1, 1 to the left. There's a lot of points on that one. And then draw your line through it. If you weren't sure if you did it right, you really could distribute this and solve for y to see if it graphs in the same form, y equals mx plus b. We're just learning a shortcut from our equation, our point slope form. Again, it's called point slope because there's a point that we find and a slope right in it. So this one I would like you to try on your own. Pause the video and then click play to see if you got it right. Our slope, first, in front of our parentheses is 2, or as a fraction, 2 over 1. And then our point that we need is x and y. So x is just 5. And y, to get this positive, we need a negative from here, so 1 also has to be negative. Those two negatives would make the positive right there. So y is -1. So if we graph this, x, y, x is 5 to the right, 1, 2, 3, 4, 5, and y is, not up 1, down 1. And then we're going to use our slope to create our line. Rise over run. Up 2, 1 to the right. Rise 2, 1 to the right. Or down 2, 1 to the left. And create our line. Notice on this one, our slope was positive, so our slope man would be walking uphill. This one, our slope was negative, and we're walking downhill. Make sure your slope is the right direction. Now, we're going to continue to write equations in this form. We're given the graph, though, we need to write the equation. It says, find the slope. Well, we can do that. We can either use our slope formula, or just count. I'd rather just count. Then write the equation in point slope form. Pick one of the coordinate pairs. So first, my slope, rise over run, I'm really going down, -1, -2, and over 1, 2. So 2 over 2 is just 1, so our slope is really a -1. And then we can pick which point we want to use. You can use this point or this point. So if we write this, we could have y minus, I'm going to use this point first, y minus 1, equals our slope, which is -1, and then in parentheses, x minus x1, which is also 1. Or you can use the other point and do y minus, using this point, y1, which is 3, equal to our slope, which is -1, and then in parentheses, x minus x1, which is a -1. Those two negatives make a positive. So both of these are correct answers. I would accept either one of them on the test. You do not have to write both. This one, let's start by finding our slope as well. From this point to this point, I'm rising 1, 2, 3, 4, 5, 6. And I'm running 1, 2, 3. Well, 6 divided by 3 is just 2, or 2 over 1. So let's plug in our equation. Y minus, I'm just going to use this point, y minus y1, which is negative 3. That makes a positive, equal to our slope, which is 2. And then in parentheses, x minus x1, and x1 is a negative 5, again making a positive. Or you could write the other equation. In this one, I kind of went through the point there. This point is negative 2, 3. So we would have y minus 3 equal to our slope still is 2. And then in parentheses, x minus x1, which is a negative 2. Those make a positive. So if some of you might be wondering why I can accept either of these, if I were to distribute and solve for y, we would have the same equation in the form y equals mx plus b. So these are really the same line. We're just using different points to express the same line. So we did a couple problems like this the other day. It says, tell whether the data in the table can be modeled by a linear equation. If possible, write an equation in point-slope form that relates y to x. So first, in order for these to be a linear equation, they have to form a straight line. So if we plot some points and they form a line like this, well, that's not a very straight line. They need to instead form a nice straight line, or from one point to the next, our slope should be the same. So we're going to take a couple of these points and first figure out if it is a linear equation, if it is a nice straight line. So I'm going to take this point first, and this point, xy, is really just 3, negative 4. And then this point is 6, 0. So let's find the slope between those 2 points first. And I'm just going to write my slope formula down here. So if we plug these in, this is xy, my first point, xy, my second point. So our first slope here is y2 minus y1, so 0 minus a negative 4, making a positive. And then on the bottom, x2 minus x1, 6 minus 3. Well, 0 plus 4 is 4, 6 minus 3 is 3. So slope we leave as a fraction, don't convert this to a decimal. It's 4/3. And then I'm going to pick my next 2 points. It doesn't matter which 2 you pick. I picked these 2 first. I'm now going to just pick the next 2, or these 2. I also like this one here because it has 0. So I'm going to list these points out. I'm just going to put them over here. This one is 6, 0, and this one is 9, 5. So these are my points, xy first point, xy second point, and let's plug them in. So y2 minus y1, we have 5 minus 0. And then x2 minus x1, we have 9 minus 6. So if we simplify this, 5 minus nothing is still 5. 9 minus 6 is 3. So this one's 4/3 and this one's 5/3. Close, but not quite. So these are not a linear equation. If it was a linear equation, we could write this with our slope, if it was the same, and pick a point. So let's try the second one. I'm going to pick these first 2 points, just because they're the first 2. You can pick any 2. And I'm going to write them out. 1, negative 1.2, and 3, negative 0.8. And I'm going to plug those into my equation. Oops. x1, y1, x2, y2. So y2 minus y1, following our equation down here, we have negative 0.8 minus a negative 1.2. Those 2 negatives make a positive. And then x2 minus x1, 3 minus 1. So negative 0.8 plus 1.2, well, to get from 0.8 to 1.2, it's 0.4. And there's more positive, so it should be 0.4. and 3 minus 1 is 2. If we solve the next one, I'm just going to pick two other points. I'm going to pick these two. It shouldn't matter which two you pick, they should form a nice straight line. This point is 4, negative 0.6, and this one is 6, negative 0.2. Running out of space there. So this is xy first point, xy second point, and we're going to plug them in. So y2, which is negative 0.2, minus y1, which is negative 0.6. Those make a positive. And then on the bottom, x2 minus x1, which is 4. So negative 0.2 plus 0.6, that also gives us 0.4. And 6 minus 4 is 2. So these are the same. We can assume that if we get the same slope twice, it will continue all the way through here. So we need to write an equation, it says, in point-slope form, which is what we've been working with today. So our slope we just found right here, and we need to pick a point. Doesn't matter which point you pick, I'm just going to pick the first one. So y minus y1, which is a negative 1.2, those make a positive, equal to our slope, which is 0.4 over 2. And then in parentheses, x minus x1, and x1 is 1. Now if we wanted to, we could use any of those other points. We could also convert this slope to a decimal. However, for the sake of time, I'm just going to leave it. Our last problem, talking about traffic delays. It says, from 1990 to 2001 in Boston, Massachusetts, the annual excess fuel or extra fuel in gallons per person consumed due to traffic delays increased by about 1.4 gallons per person each year. In 1995, each person consumed about 37 gallons of excess fuel. So it says, write an equation that gives the annual excess fuel in gallons per person as a function of the number of years since 1990. Well, they give us equation. We need to write an equation, and they don't tell us. So I'm going to tell you, write it in point-slope form, which is y minus y1 equals our slope, x minus x1. So right now, it's 1.4 gallons per person. Well, if first we think of the equation y equals mx plus b, well, per person, we're using 1.4 gallons for every single person. So this is really our slope, what we're doing multiple times, over and over and over again. So this is really our m. But we don't have b. We don't have what our starting excess fuel is that we would use or whatever. But we know that in 1995, each person used about 37 gallons of fuel. So we can write this piece of information right here as a point x and y. So we know that the 1.4 gallons per person is each year. So the 1.4 gallons, which is our slope, is multiplied by the number of x, which is the years. So this year is really from 1990. Well, what year is it if it's 1995? How many years has that been? Well, since 1995, if we subtract 1990, it has been 5 years. So our years is x, because it's gallons per person per year. Also time. Anytime you have a time, it's always going to go on your x-axis. Just a hint there. But x is going to be 5, and then y would give us our total number of gallons of fuel that we used, which was 37. So we have y minus y1, or y, which is 37, equal to our slope. Oh, but our slope is really 1.4 right here. And then x minus x1, which is 5. So that answers part A, write an equation. But now part B says how much excess fuel was consumed per person in the year 2001. Well, we could solve this whole thing for y. Otherwise, we know x is our time or number of years, so we're going to plug in the year 2001 for x. Well, we're really not going to plug in 2001. We're going to plug in how many years is that since 1990. Well, 2001 minus 1990. You could just count up from 1990 to 2000. That would be 10 years. Plus one more would be 11. Or just use your calculator. So we're going to plug in an 11 there. And this is part B. So let's actually solve this. 11 minus 5 is 6. So we have 1.4 times 6. So 1.4 times 6 gives us 8.4. And then all we have to do is add 37 to both sides to get y by itself. So y would be 37 plus 8.4, which gives us 45.4. And y, if we look back up here, y was our number of gallons. Alright. Here's your homework. Good luck.